Hello and welcome back to our Algebra 2 work. I apologize for that first lesson. Didn't realize that I had my phone where it was sideways, so you basically have to watch it sideways. I apologize for that. So I'll get that fixed this time here and jumping right back into it. Don't want to waste too much time. We left off with numbers 3 through 14. That's what I wanted you to try. I have 14 right here, and then I'm going to go through the rest of this this chapter review. Several different problems, and then what I want to do is tomorrow, and you guys, I'll throw something down on the stream so you already know this, but tomorrow I would like to do a live question and answer session where you guys can hop on, you can ask me questions, I can see your work and all that sort of thing. They're getting ready because what we're going to do is today we're going to do this right here. Tomorrow I'm going to do that Zoom, and then Thursday, which is going to be your next day, we're going to have our test. And so want to make sure you guys are ready for it. Want to make sure you're prepared for it. And if possible, we might have to move it back one more day. But that's the goal anyway, so that we can get into chapter 12, get done with this chapter, chapter 11. Anyway, let's go ahead and get into number 14 here. So taking a look. The question, by the way, because this, I just drew what it has written for us already. But if you read the question, or if you're on there, page 518 is where we're at. It says, Mr. Davis wants to enclose a triangular field that would say with electrical fencing. A survey of the adjacent field shows the other field is at an angle of 112 degrees with the roadway, and that the length of the shared side is 212. If its lot's road footage is 156, how much fencing does he need? So what we're trying to figure out is what the total distance of fencing this man needs all the way around his triangle. I know this side, I know this side. And I have an angle here. But the first thing you should realize is that this 112 degrees is not the angle inside my triangle. It's not the angle here. This angle is actually going to be 180 degrees minus 112. And so the reason being is a straight line right here is 180 degrees. If you have a line that divides it, then the two angles on either side of that line add up to be 180. So this one's 112. What I'm actually working with here is 68 degrees. All right, you guys might not be able to see that well. I'm going to write on my paper also. But what we're trying to find out is what the total amount of fencing that this guy has to have. So I'll come back to my problem. All right, I have it all set up. As I just mentioned before, this is going to be 68 degrees. That's what we're actually working with. I'm not working with the 112. The 112 is just there to help us get started. So I've got a side, an angle, and a side. I have side, angle, side. The only way I can solve side, angle, side is by law of cosine. So what I'm going to do is, remember, once again, what we're trying to answer is the total road footage, fence that I need. So I need this whole length, all three sides. I have two sides. I just need this last one. I need this, we'll call this side C. All right, I need that last side C. Then I can add all three sides up and get my answer. So I'm going to set up my law of cosines. Right, and remember, if you remember from yesterday and also from our working here and from your paper, your little cheat sheet there, you got C squared equals A squared plus B squared minus 2AB cosine of big C. All right. So there's my law of cosines. Let's plug in our numbers. I got C squared equals, we'll go A squared is 212. Hopefully you guys brought your calculators home for this one. Then I got 156 squared minus, put that parenthesis there, 212, 156 cosine of 68. All right. So all I've done is plug in my numbers. Here's my A, here's my B, here's my A once again, here's my B once again, here's my cosine of 68 degrees. So let's go and simplify. So go to my calculator. I got 212 squared is 44,944. That's a big number. 44,944 plus 156 squared. 156 squared, 24,336. Minus, I'm going to go 212 times 156 times 2, 66,144. Cosine of 68. So there's my new line. All I've done is square 212, square 156, multiply 2 times 212 times 156. That's right here, 66,144. Cosine of 68. Now I'll come in, combine these two together, and then do my calculator work here. Subtract that away from this combined number, take the square root, and I'll have my answer. So I'll come here, I got c squared equals, I got 44,944 plus 24,366, or sorry, 336 equals 69,280. And then I have that minus 66,144 cosine of 68. So from here, in your calculator, and I'll scroll down just a little bit so you can see that there. In my calculator, I'm going to go first, I'm going to put this in. All right. So I'm going to put 66,144 cosine of 68. Gives me 24,777. Then immediately I'm going to take 69,280 minus, and this is where we hit second answer, equals, so 44,502 and change. Don't get rid of those numbers, by the way. So I got 44,502 ... Then immediately take that number and take the square root of it. So in your calculator, here's my number that I have. I'll just hit second square root, second answer. Hit equals. And there is my side C. Side C equals 211, because my 5 here would round my 9 up to a 10. Not round it up. So 211 is side C. Yay, I finished. Almost. All right, not quite. Last thing I got to do is answer my question. The question is, how much total fencing is this guy going to need? So I know that C is 211. To find the total, all I'll do is take my calculator, add up the 3 sides, and that will tell me my fencing. So this guy's going to have to need 579 feet of fencing. I'll put it, I don't know, let's put it right here. Ta-da! So there's 14. Ta-dee-da! Now, on from the trigonometry into verifying identities. All right, so we're moving on to next. So I'm going to number 21 is where I'm at. I'm flipping over to 21. You have to do 18 and 19, but you have those already written for you. All right. If you remember, those are your sum of difference identities and your negative angle identities, both. All right. So number 21, we're getting into the directions say simplify. So what I'm going to be doing is taking my cheat sheet, which you guys can use for your test still. That's fine with me. And I'm going to take that cheat sheet and you guys look at your identities, see what all you got going on, and see where you can connect, if you will, or what to plug in, what to substitute. So right now, in my problem, number 21 says sine squared of x minus 1. Well, what I want to do, if you remember, is I want to find what identities do I have that include sine squared of x and a 1, and see how I can manipulate it and what I can turn it into. Well, if you immediately went to your Pythagorean identities, the Pythagorean identity states sine squared plus cosine squared equals 1, right? That's my original identity, my Pythagorean identity. Well, if I want to make this, make it look like one side is this, sine squared of x minus 1. How would I do that? How would I make